Hi guys, it's me, Miss M. I'm going to do page 30, or I'm going to do 4 of them on page 30. I'm going to show you how to use the solubility table and the rules underneath because there's a couple that aren't showing up. Okay, so let's look at the first one. Okay, there's a couple of things that we need to make sure we're clear on. AQ means that it's aqueous. I can dissolve it in water. Okay, and that's right here also, able to dissolve in water. Now, what I need to use this solubility table on page 27 for is to figure out, are either of these soluble? Okay, so I have to look at the solubility rules to tell if it's soluble or not. Okay, so here is aluminum chloride. So let's look here. Okay, so I wrote some things down. Here we've got to be careful. On this chart, capital S means soluble. It dissolves in water and it will be aqueous. If I get anything, SS, I, A, or D, they are insoluble. They will form or precipitate, and I will get a solid. Okay, so let's look at aluminum, and I'm going to go over to chloride, and it's a capital S, meaning that it will dissolve in water. Okay, so for this, I'm going to put aqueous. He is not going to form a solid, so I'm going to write soluble above him. Okay, now we've got to look at this guy, and I'm a little scared because there's more than 2 elements here. I've got sodium and acetate, so let's look here. Okay, here's my sodium, here's my acetate. I've got a capital S, meaning that it will dissolve in water. Okay, so he too is soluble, and he will form aqueous solution. So remember when we were predicting double replacement reactions, aluminum and acetate went on a date, sodium and chlorine went on a date, and it wasn't a love connection. So they switched partners. Well, aluminum and chlorine, they're not getting married either. They're not forming a solid relationship. And sodium and acetate aren't forming a solid relationship. So this is going to be no reaction, no solid formed. Products are soluble. Okay, so that's what I'm going to do. Okay, let's look at number 2. Okay, so I've got ammonium sulfate is aqueous. It's in a solution. I've got lead nitrate, which is aqueous in a solution. So I need to see when lead and sulfate make a connection and when ammonium and nitrate make a connection, do they form a solid compound? If at least one of them does, then I have a reaction. Okay, now I luck out here, there's only one lead. Okay, so I need lead sulfate. So I've got my lead, and I'm going to go all the way over to sulfate. Oh, sorry, it's an I. If I look at I, he's insoluble. So this guy is insoluble. He will form a solid. This S stands for solid in the chemical reaction. I need to be careful because there are S in the solubility table. Now let's check ammonium nitrate. So here's my ammonium, and I'm going to go all the way over to nitrate, and that's capital S, meaning soluble. Okay, so he is soluble, so he is going to be aqueous. What do you guys think here? Are we going to have a reaction or not? Yes, a reaction. Oops. A solid is formed by one product. Okay? Now, when we did this, we made this worksheet up. We need some to use solubility table up at the top and for some solubility rules at the bottom. So let's take a peek, right? There's some we're going to look at the bottom of page 31 that are not in the table. What do we do? So there's rules. There's no way I would need a huge table to fill these in. So let's get rule number 1 because I know I'm going to need it. Group 1 alkyls, that's the lithium, sodium, potassium, rubidium, francium column, and ammonium ion soluble compounds. So these guys are always aqueous. Okay, so let's look at which one. I want to look for 8. Okay, I've got potassium and sulfur. I've got lithium and hydroxide. Okay, well, if I look, potassium, fantastic. I don't have on here sulfur, right? So this is a sulfide compound. Well, what I'm going to need to do is I'm going to need to look at a rule and see if I can find a sulfur compound. Well, I'm at rule 6, sulfide compounds. Okay, so rule number 6. Look, ones are all soluble. So we really shouldn't need to look at sulfur rule, but we're double checking. All solid compounds are insoluble except with group 1 or 2. Wait a second. Potassium's in group 1. So this guy is going to be soluble, which means he is aqueous. Okay. Now, lithium hydroxide. Well, lithium's group 1. He is always soluble. So he is soluble also. Right. I can use rule 1. And he is going to be aqueous. So what do we do up atop when I had 2 aqueous solutions? I'm going to have no reaction, both soluble compounds. Okay. I'm going to do another with you. I'm going to do number 7 with you. Okay. So here, if I look, I've got potassium nitrate. That's in dark. Okay. And here I've got iron hydroxide. Okay. So let's do the potassium nitrate one first. Here's my potassium. Here is my nitrate. It means that potassium nitrate is soluble. So that means he is going to be aqueous. Now, iron hydroxide. Uh-oh. I need to figure out which iron it is, right? And I can't say, well, it doesn't matter because if I look, there are some differences in the solubility table. So let's go and see if we can calculate the charge. And I'm going to do that up here a little bit so we have a little bit more space. I know the hydroxide is -1, and I've got 3 hydroxides, so this whole side's -3. Well, if this whole side's -3, this side must be +3. So I am looking at iron 3 hydroxide here, okay? So I'm going to go iron 3, and then I'm going to go over to hydroxide, and I get a capital A. Well, like if you look, soluble in acid. Well, I haven't dealt with acid yet. Let's keep reading. Insoluble in water. Okay, so he is insoluble. He forms a solid. I'm going to use an S. This reaction will happen at least one solid is formed. All right. So sorry about those of you who tried to watch my first video, having problems with the sound. I hope this helps. Okay, keep asking those great questions. Miss you.